In this video, we will begin to understand and use electrical schematics. To understand a schematic, the technician must first understand the difference between a series and a parallel circuit. Series circuits are generally used to control loads. Parallel circuits are generally used to energize multiple loads. In this series drawing, the L1 wire goes through each fixture. What would happen if I remove one bulb? All the bulbs go out. In this parallel circuit, the L1 wire goes to each fixture. What would happen if I remove one bulb? Only the bulb removed goes out. Series circuits are generally used to show multiple control switches. Any of the switches in the series can interrupt the load. Parallel circuits are generally used to show multiple loads controlled by the same switches. The following switches are shown in their normal position. Normally open single pole single throw switch. Normally closed single pole single throw switch. Normally open double pole single throw switch. Normally closed double pole single throw switch. Single pole double throw switch. Double pole double throw switch. The following symbols are attached to the switch to identify its purpose: temperature, pressure, float, flow, and sail. The identifying symbol attached to the switch denotes its purpose. Switch closes on temperature fall. Switch closes on temperature rise. Switch opens on temperature rise. Switch opens on temperature fall. Switch closes on pressure fall. Switch closes on pressure rise. Switch opens on pressure rise. Switch opens on pressure fall. Symbols are used to identify other parts of the equipment: open contact, closed contact, a load, a letter is in the circle to identify the load, transformer, and overload. Wires in a schematic are depicted by different methods. A factory line voltage wire is depicted by a solid line. A factory low voltage wire is depicted by a dotted line, and a field low voltage wire is depicted by a dashed line. In a ladder diagram, the transformer separates the high and the low voltage sides of the system. In this basic cooling ladder diagram, the wires and controls are shown in color to help the student trace the circuit. The legend identifies the controls and loads in the circuit. In the low voltage portion of this drawing, identify the series circuit and the name of switches. Thermostat on switch. Thermostat temperature switch. High pressure switch. Low pressure switch. How many parallel circuits are in this drawing? There are two parallel circuits. On the low voltage side, the indoor fan relay and cooling contactor coils are parallel. On the line voltage side, the compressor and the condenser fan motor are parallel. We can now apply the sequence of operation of this cooling circuit. Thermostat switch turned on. Temperature switch closes. 24 volts sent to the cooling contactor coil and the indoor fan relay. The cooling contactor switch closes. The condenser fan and compressor turn on. The indoor fan relay closes and the indoor fan turns on. The high pressure switch opens. The compressor and condenser fan motors turn off and the indoor fan motor remains running. This drawing is a basic gas furnace pictorial schematic which is an illustration of the wiring of the equipment. The legend identifies the wire voltage and color. The switches are identified by symbols depicting the position of the switch with the furnace not turned on. All modern furnaces have a control board, and the technician needs to understand the sequence of operation. First, the thermostat switch closes. Then the inducer motor starts. The pressure switch closes. The igniter is energized. Board checks the rollout switch and limits. The gas valve is energized. Flame sensor verifies the flame, and after a delay, the blower starts. Join me on Facebook at Certified HVAC Training, where we share training.